Group-wise maximums are extremely common in reporting and analytics, like top-performing products, latest sensor readings. Interviewers use this to test your understanding of subquery execution plans, CTE decoupling, and database performance optimizations. In SQL interviews, retrieving the top records within a group is a classic pattern. For department highest salary, we need to find the highest paid employee in every department. While it looks like a simple lookup across our employee and department tables, a naive nested query will trigger a massive performance penalty. Let's examine why. Here's the trap most candidates fall into: a correlated subquery. We filter the outer employee table by matching its salary to the maximum salary from a subquery. This subquery filters by matching employee department ID to the outer query's department ID. Although it returns correct results, it is an algorithmic nightmare. Why is it a nightmare? The inner query depends on the outer row. This means the database cannot run the subquery once and cache it. Instead, it must re-execute the inner query once for every single row in the outer table. This results in an O(n)² execution tax, causing performance to collapse as your data grows. To write production-grade SQL, we decouple the nested logic using a common table expression, or CTE. First, our CTE pre-aggregates the maximum salary for each department ID in a single pass. Then, we join our main employee and department tables to this pre-computed result. This executes in O of n log n time, eliminating the correlation tax entirely. A critical edge case in top-paid lookups is handling ties. If two employees in the same department both earn the maximum salary, a robust solution must return both. Because we join on both the department ID and the maximum salary from our CTE, all matching employees are returned naturally. If we used row ranking functions, we would have to be careful to use dense rank rather than row number. Lock in this nested logic blueprint. Correlated subqueries execute once per outer row, yielding O(n)² complexity. To optimize, decouple the aggregation into a CTE and join it once. This guarantees O of n log n execution and clean tie handling. Keep this blueprint in mind, and you will pass your system design and SQL interviews. Let's analyze the correlated subquery approach. Time complexity, O of n². Space complexity, O1. Re-evaluates the inner subquery for every single employee row, creating a nested loop pattern. Let's analyze the CTE with join approach. Time complexity, O of n log n. Space complexity, O of n. Pre-aggregates maximum salaries per department in a single scan, then joins the result efficiently. The interviewer will then ask, what is the difference between a CTE and a subquery? A CTE is a named modular query block that improves readability and can be referenced multiple times in a single query. A subquery is inline, and if correlated, executes repeatedly for every outer row. The interviewer will then ask, how would you rewrite this query using window functions? We can use dense_rankover, partition by department ID, order by salary DESC, in a subquery, or CTE, then filter the results where the rank is equal to 1. The interviewer will then ask, what happens if an employee has no department? If department ID is null, an inner join with the department table naturally excludes them. If they should be included, a left join is required.